Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the relations of energy equations and heat to work. The forms of energy already discussed, which constitute the total energy of a system, can be contained or stored in a system, and thus can be viewed as the static forms of energy. The forms of energy not stored in a system can be viewed as the dynamic forms of energy or as energy interactions. The dynamic forms of energy are recognized at the system boundary. The dynamic forms of energy are recognized at the system boundary as the quiescent, and they represent the energy gained or lost by a system during a process. The only two forms of energy interactions associated with a closed system are heat transfer and work. An energy interaction is heat transfer if its driving force is a temperature difference. Otherwise, it is work. A control volume can also exchange energy via mass transfer, since any time mass is transferred into or out of a system, the energy content of the mass is also transferred with it. For the energy equation, equation 2.6, the applicable conditions are for closed system, any working fluid, and any process. For the energy equation, equation 2.11, the applicable conditions are for open system, any working fluid, and any process. For the energy equation, equation 2.13, the applicable conditions are for steady flow, open system, any working fluid, and any process. Of course, it is obvious that equations 2.6, 2.11, and 2.13 are in different forms and have their own applicable occasions, but there are also commonalities. Starting with equation 2.13, if the increment of fluid kinetics energy and the increment of gravitational potential energy in the steady flow energy equation, equation 2.13, are regarded as energy temporarily stored in the field and combined with the shaft work, the work is equivalent to the technical work in the energy equation of the open system. Equation 2.11 is obtained. Starting with equation 2.11, if the enthalpy in equation 2.11 is written as the sum of thermodynamic energy and flow work, and the technical work is written as the algebraic sum of intake work, expansion work, and exhaust work, equation 2.6 is obtained. Equation 2.6 reflects the conversion of thermal energy and mechanical energy. It shows that in any case, the expansion work can only be derived from the reduction of the internal energy of the thermodynamic system itself and or from the heat supplied from the surrounding. This is the essence of heat to work. The difference is that the form of work output by different thermal system is different. For a closed system, all expansion work is for output. For a control volume, a part of the expansion work is used to make up the difference between the exhaust-driven power and the intake-driven power, and the rest is available for output. For a steady flow process, the expansion work is not only used to make up the difference between the exhaust-driven power and the intake-driven power, but also used to increase the kinetic energy of the fluid and to increase the potential energy of the fluid. The remaining part is provided for output. By now, the difference and internal connection between total work, expansion work, technical work, and shaft work have been expressed. The magnitudes of expansion work, technical work, and shaft work depend largely on the process. Okay, that's all for this task. Thank you very much, and see you next time.